All right, once again we have another question involving an orbit. Here we have a space shuttle moving at 27,000 kilometers per hour. So they give us the velocity of the shuttle. But of course, we don't like kilometers an hour in physics, so we have to convert that to meters per second. So I can get rid of the kilometers. There's 1,000 meters in 1 kilometer, and then get rid of the hours. And since the hours is on the bottom here, I want to place it on top of my conversion and get seconds. And there's 3,600 seconds in 1 hour. And when I do all of that, I get a velocity of 7,500 meters per second. Okay, now any orbiting question, the force that's keeping the object in orbit is the force of gravity. So my net force, which we're calling the centripetal, is Fg. And because they give us information regarding velocity, I'm going to write my centripetal force as mv squared over r. Now force of gravity as usual is g times the satellite times the Earth all over the distance between the two squared. And once again, the radius of the circle is the same as r, which is the distance between the two masses. So this will cancel with one of those. The moving object, the satellite's mass, is gone. And now we have a way to calculate r. So to get r by itself, I multiply both sides by r. I get rv squared is equal to g times m. And then divide both sides by v squared. So my radius of orbit will be g, mass of the Earth, divided by v squared. Now you have all your information there, but you won't get the answer that you see in the lower left, because you're going to get a value that takes the satellite from its location out at the edge of the circle. R is the distance all the way to the center of the Earth. And we want to know how far above the Earth the satellite has to be. So once you get your value for R, you've got to subtract off the radius of the Earth. And when you'll do that, you'll get the height above the surface of the Earth. And you will get h is 7.1 times 10 to the 6 meters. Give it a try.